we left off. We're about to talk about vertical aspects and what's going on around vertical aspects. Then we're going to talk about horizontal aspects, then we're going to talk about something like this. What if I started you off today and said, hey, ready, set, go?
Oh, yeah.
Yeah.
Oh.
What's wrong? Why are Emma's eyes so big?
That's a lot.
No, she's like, whoa. Just kind of shocked.
Yeah, I know why your eyes so big.
Oh, stop. That's not what I meant. Right here. If I had just shown you that, and I said go.
Oh, yeah.
This could be a test problem that's coming next Tuesday.
Wait, you can't cross the x squared out, right?
No.
That's all I remember.
It's a good idea, though. Now hold on, wait a minute. Okay. Here's the dilemma that we need to try to fix today. The dilemma that we need to try to fix today is how on earth are you supposed to figure out what that thing looks like? And Nathaniel came up with a good idea that a lot of you, if you were desperate, would totally do. The x squareds don't cross out, right? What was his brain wanting to do? And a lot of yours would want to too.
Okay.
Ha-ha! But the poor little kid. You can't just start seeing things and start being like, because aren't there technically? Yeah, aren't there factors for each?
Can't you multiply by
Okay, fine. You guys just turned in a test that you had to do corrections on, true?
Yeah.
Some of you far more than you ever wanted to have to do. True? I just told you a test is coming when? Tuesday.
No.
So, or Wednesday, but Tuesday sounded more fun to say. So Diego, thanks. Tuesday, you got it. So the rest of the class, what do we want on the next test score?
100%.
Something higher. Can we just go with higher? Now some of you were like, no, I'm good, but you kind of slacked off a little bit. Some of you were like, nope, I'm bad, and you still slacked off a little bit. So, focus. I'm showing you one of the hardest types of problems on the test, and we don't know how to do it. Maybe we need to like zone in, right? You gotta focus. If you have coffee, show me that you deserve the coffee and I'm gonna actually help you pay attention as opposed to just be hyper and more than normal.
I've never had coffee. It's like the first time.
Experimental. See how it goes. But so far you were paying attention and wanted to cross off the x squared, that's good. Although, don't do that. So, the x squared, we can't cancel out, so what are we supposed to do? Now some of you guys just said factor, right? I mean I haven't. I guess x plus 2 times x minus 2 all over
X minus 2 plus times x minus 2.
Oh!
Wait.
From yesterday, if you remember anything from yesterday, we have a removable discontinuity because what? Removes. Now wait. You're going to see this in homework when you start like checking answers in the back of the book, calc chat sort of thing. Just because we are allowed to do this, which we most definitely are, and just because we're allowed to rename this or restate this in another factored form, doesn't mean that we can ignore the problem that was there. I'm going to move this because I'm running out of room, but I do want to rewrite this. But guys, when I rewrite it to be x plus 2 over x minus 1, what else must I write to not lose any of the meaning of the first form? Well, but if I rewrite it, oh, don't worry, we still have like 3 pages. We're just looking at it. When I rewrite it as x plus 2 over x minus 1, why am I going to take half of what Kimia said and I'm going to totally ignore the other half? She said x can't be 1 and x can't be 2. She's right, but why am I only writing this one? The denominator's still there. The problem is still very apparent if you know math. Like, oh yeah, of course x can't be 1. It's right there. That's okay. That's non-removable. Oh. So yesterday we were talking about discontinuities, removable ones and non-removable ones. So from the very beginning, this guy's domain, Kimia, you're right, the domain said x can't equal 1 or 2. But I only need to write the second one to remind myself that I took away the other. Now, hold on, pause. We're still not to an answer. We're still not to a graph. Does it at least look better than it did?
Yes.
Okay. But if it still wants me to sketch, man, it'd be nice for me to know. Well, okay. With a removable discontinuity, what we saw yesterday is we can actually figure out where the hole is by taking the x of the hole that we removed and plugging it in. Wait, not there. If we plug it in here, we're going to have a 0. That's bad. Plug it in here. 2 plus 2 is 4 over 2 minus 1 is 2. 2 plus 2 is 4 over 2 minus 1 is 1. Sorry. I'm going to end up with 4. Because I can say, hey, it's this guy, but the point at 2 is not really a point. He's a hole. Okay, that's good. We know there's a vertical asymptote at 1, because he's the non-removable. But yesterday we figured, okay, we can plot a hole, but a vertical asymptote, all we can plot is a vertical dotted line. How do we know what's going on around the asymptote? These are little baby pieces getting ready for this hard problem that we're going to have to figure out how to do. But before we do that, remember yesterday? Talking about holes and vertical asymptotes? This guy, by removing, was super easy. He was a line. Graph him, put the hole at the place where he's not allowed to exist. But vertical asymptote, it was like, yay, nothing reduces. Yeah, okay. Oh, okay, I know there's a discontinuity at, but what does my graph look like? This is the problem we're trying to figure out. What on earth, or how on earth do we know what a graph looks like if all we know is that there's a vertical asymptote? Holes are nice, you get rid of them and something smaller is left, but you guys just saw an example that's coming where it's like, okay, we got rid of something, but we still don't know what this guy is. But don't worry, because we have clues, we have hints, we have things to find that should get you the best possible graph. But to find all of these, well, the intercepts we already know. The holes we already know. Vertical asymptotes, we got to do a little more work. Horizontal asymptotes, we got to peek at today and then put it all together and see if we can figure this out. So vertical asymptotes. We know there's a dotted line, but if we could know how the function is coming into the dotted line, we'll know more about our graph. So, trying to learn more about complicated graphs with vertical asymptotes because they don't let us get rid of stuff. They're kind of stuck, aka non-removable discontinuities. Here we go. We have an easier function, negative 3 over x plus 1. We want to know what he looks like. We know that this is not a hole. We can't factor and get rid of anything. So yeah, I mean, we know the domain. Alright, that's hard words bad. I have no idea. It's a pen trace. X cannot equal negative 1. Boop, boop, boop. Not just can x not equal negative 1, there's a vertical asymptote at negative 1. But how do we know what's going on around negative 1? If we were to try to graph this guy, I mean, we know one of 3 different cases, or the vice versa of that, so I guess 4 different cases might happen. But if I try to start a graph right now, I mean, kind of boring. I'm kind of missing a lot. I know there's an asymptote, I know it's at x equals negative 1, and now I'm stuck. Well, am I stuck? Could I, just make a table and start putting random points and hopefully getting a picture? Yeah, so if worst comes to worst on the test, you could randomly start making a table, plotting points, and hopefully getting a picture. But I'm going to be really, really strategic with specifically checking right close to the vertical asymptote. Now guys, there's weird stuff that could be going on away from the vertical asymptote. My function could be going like infinitely up or down or oscillating like a wave. I don't even know what's going on away from the vertical asymptote as far as in general with any graph with a vertical asymptote. But I do know what's going on as I come in, and it's only select few cases as to what could actually be happening. So I'm going to get closer and closer and closer to my vertical asymptote in a table or in a graph. Throw this function into your y equals. Throw this function into your y. Now I know, you're like, I'm using my calculator. Duh, I'll just go look at the graph. But wait, we're building up to not using our calculator? We're building up to it, so we're using our calculator for a little bit. We're building up. So if I throw this into, well, if you throw this into your y1, and I'm getting you guys to do it in your calculator, I've already shown you what's going to happen. But I want to make sure that you have your settings right if you need to do it for homework tonight, okay? So, settings in your calculator. How am I getting these numbers, and can you get them too? And what do you have to change to get there? First of all, if you go to your table, not stat plot. What am I talking about?
Second graph.
Second graph. If you go to second graph right now, most of you would not have this because number one, you didn't put this into your y1. So put it in your y1. You have to have a y1 for things to show up. What else do you have to do to get here?
You have to do table setup.
Which is second window, Nathan?
Yeah.
Second window. You have to change the automatic generation of the table to be an ask option instead. Ooh, good question.
Dependent. Right?
You're looking for the y.
Why is the
But do you want them to ask you what the y is? Or wait, Aiden, hold on, good question. Do you want them to ask you for the y's, the dependent, and say, what are the y's, or do you want them to give you the y's?
Give them the
Okay, so if you want them to give you the y's, leave dependent on auto. You're like, no, please, you give it to me. But what are you going to give to it to do these weird, like, 0.9, 0.99, 0.99? Independent. Independent needs to be asked. You want to be able to put in whatever x you want. So, second window, independent is ask. If someone in your group, you're looking around real quick, check it out. If they don't have a calculator, can you just kind of show them what you're doing? So negative 3 over x plus 1 is in your y1. Your second window has the independent as ask. And now go to your second graph. Why am I plugging in stuff like negative 0.5 and negative 0.9 and negative 0.99, negative 0.99, negative 0.9999, and negative point, wait, 999? Careful, your calculator can only fit so many digits, and so then it rounds, even though it's not really rounded, but it looks like it, but it's not. Yeah.
When I plug in the x's, it gives me the second window.
Oh, check your y equals. Do you have this guy there? There you go. You guys tell we're coming from above? Maybe above's a complicated way of saying it. We're coming from the, kind of more from the right, I suppose.
When I plug in -1, it just says error.
Why does it say error?
It doesn't exist.
So Nathan, we're not plugging in -1. Check it. I know mine shows a -1, but what is it actually? The calculator doesn't have enough room to show all of the decimal places, so it rounds to show you the best version of what you put in that it can give. But in all reality, I did plug in -1. From the right, from the left. We talked about to the right and to the left. Now we're coming from the right and from the left. Wait, can we double check real fast? Because you can set equal to 0. I can square root add the 4. Let's assume you got your calculator to match what mine did. What's this telling you? -6, -30, -300, -3,000, -3 with 5 zeros after it. What's it telling you? My function's going down. From what direction? Because remember, think vertical asymptotes. From the right, where's -1/2 on a number line? Where's -0.9? Where's -0.9? I'm coming down from this direction. Does that make sense? My function is somehow coming down from that direction in towards the vertical asymptote. But if you look on the other side, from the left instead, -2 is over here, -1.1 is over here, -1.01, -1.001. We are approaching. Hey, in math, there's a snazzy symbol for the word approach. Remember what it is? So as we approach from the right of the vertical asymptote, or from the left of the vertical asymptote, from the right, he's going down. From the right, he's going down. From the left, you sure it's going down? Mine's not going down. 330, 300, 3,000. He's going up. You don't have to be astounded by it, but you understand it. Now, so far, do you have the entire graph? Yes or no? Nope, all we know is what's going on around the vertical asymptote. But do you guys remember the one that I showed you just a second ago, the really nasty one? How do we get like a perfect graph? Well, there was an x-intercept, there was a y-intercept, there were vertical asymptotes and domain and horizontal asymptotes. We're going to talk about more clues, but for right now, do we at least know what's going on around the vertical asymptote? Yes. Now, hold on, just a few of you are like, wait. I could have known this without doing any of that crazy go to my calculator work. Is anybody thinking that? Please tell me someone's thinking that. How can we have figured out roughly what this looks like without even going to our calculator? What does this look like that's a lot easier than the one at the beginning of class?
1 over x.
The parent function 1 over x. If the parent function, well, I guess we would call him g, but if this is our parent function 1 over x, wait a minute, what transformations happen to this student? Wouldn't this be a -3 times 1 over x plus 1? Didn't it shift 1 to the left and get vertically flipped and have a vertical stretch? Maybe I should know what this guy looks like. Oh wait, hold on. That wouldn't be 1 over x. Remember, before all the transformations, 1 over x looks like this at 0, right? But if I shift him 1 to the left and then flip him, oh, okay. So maybe this guy, you should have been able to kind of think through parent function stuff and been able to figure out what he looks like without all this work. Not always the case. It's not always the case. And so, to combat not always being the case, can I show you a mathematical way? Because the point is, we're not using our calculator, or we're trying to get to where we don't have to have it. Basically trying to increase your abilities for dealing with functions that you haven't seen before and you haven't memorized. One's beyond y equals mx plus b. One's beyond y equals ax squared plus bx plus b. I know you should know what this guy looks like, but I'm warning you about that nasty one to come. What about him? So in preparation, let's stick with this easier guy and think, what if you did not have your calculator? We know what's supposed to happen. How can we do this with math? Well, let me start taking all those words that we just wrote, and can I write them in mathematical notation instead? So didn't I just say a second ago from the left and from the right?
Yeah.
So I can go ahead and start with, let's see, vertical asymptote at x equals -1. If I'm trying to go from the right of -1, that's going to be as x approaches -1. Little baby positive in the exponent spot. The one that I just wrote from the right. So I'm translating the words that we used on the page before from the right. So as, Remember how we used to say as x goes to negative infinity or as x goes to positive infinity? This time, x is coming in towards the vertical asymptote from the right. So from the right is the plus. And as I come in from the right, we're trying to figure out what's going on. Sorry, I have to come over here to switch colors because of annoyingness. Oh, you know what? I should be able to hit that and then hit that. That's I'm trying to figure out what is f of x doing. And then I'm trying to figure out from the left of negative 1. Well, what do you guys think about the notation on that one? I'm going to do as x approaches, yeah, as x approaches negative 1 is negative. Instead of you're just making up calculus notation, aka following patterns. F of x is going to approach. Well, this is a blank that we're trying to fill in. Except, I'm not having you go to your calculators this time. So we've talked about new notation, a snazzy way of writing it. From the right has a little plus, from the left has a little bit minus. But here's what I want you guys to think about. Why is the notation what it is? Why is the notation what it is? On a number line, if you're a little bit on the right of a number, are you bigger or smaller? Yeah, a little bit above, right? So, little more. Alright, we're going. Way too noisy. Little more than. Little more than. Little above. So it's negative 1 plus a little bit. Negative 1 plus a little bit. Negative 1 a little bit higher. That's where the notation comes from in some ways. How about this one? If you're on the left, if you're coming from the left, what's going on? Little less than. Little more than or little less than? Little more than or little less than? That's exactly how we do the mathematical approach. What? You didn't show us anything. Well, I showed you notation. And if I'm coming from the right, I'm a little bit more. And if I'm coming from the left, I'm a little bit less. And we know what vertical asymptotes do. In all of those cases, absolutely every single one on the page before, weren't the f of x going to some sort of infinity, either up or down? True? So I can fill in right away without even doing any math. I can fill in, I know both of them are headed to infinity. The question is, which one? The question is, which one? So I have to think little above. Sorry, guys. I know you don't know what's going on, that's wrong, but basically something's wrong with this marker. Just hang in there. Think little above, little below, and plug in and check the sign. That's our procedure. Sign. Think little above, think little below, plug in and check the sign. So instead of having to do all of these above and all of these below, instead of doing all these above and all these below and caring about the signs, well, not the signs, caring about the numbers, 6 and 30 and 300 and 3,000 and 3 with 5 zeros, that would take so long to do by hand. That's so annoying. We don't have to do any of that. All we have to do is plug in and check the sign. One a little bit below and one a little bit above. So for the first one, if I was trying to plug in something a little bit below. No, sorry, above is the first one, right? Negative 1 with a little plus. Now, I know it's awkward. I know it's awkward notation, something a little bit above. But if we were to plug in negative 3 all over who plus 1? Negative 1, but a little bit above. Now, some of you, that's too abstract. You're like, I don't know what that means. I don't know how to do it. But that's okay. Any number a little bit above. So -3 all over. How about -0.9? It's a little bit above on a number line. It's closer to 0. It's this direction. I'm just asking you for the sign. Is that going to be greater than 0 or less than 0?
Wait. So why do we put in the -0.9?
Isn't that something a little bit above, a little bit higher than, a little bit more to the right on a number line? Uh-oh, do we need to review number lines? Sorry, I didn't realize that, guys. Do we need to review number lines? Okay, pause. I'm not done yet, so why don't you give me 1/2 second to finish, and then you can think about it, okay? Here's my question. Is this greater than 0 or less than 0? Why is it less than 0? There's a negative over a positive. This guy wins. He's a little bit too small, right? A negative over a positive is a negative. Oh, if it's negative, if all of these, anything a little bit above, if all of them are going to be negative, well, sweet. I know the answer. This is going to be a negative infinity. All you need to know is whether it's greater than 0 or less than 0. So what did I do? I thought a little bit above. What's a little bit above a number -1? -0.9 or -0.5 or 0 or 1 or 10 or 15. No, a little bit above. Okay, -0.9. Just ask yourself, greater than or less than? Well, a negative over a positive is a negative. That's less than. Okay, cool. Negative infinity. Nathan, does that answer your question?
Yeah, I got it.
So what's going to change when I now need to think of a little bit below? Exactly. I'm going to do a little bit below, which is a little negative notation-wise. I'm going to do -3 all over. Who plus 1? Sure, -1 point anything, but how about -1.1? Well, actually, if I was using my notation, I wouldn't have even written that. I would have just been super snazzy and been like, oh, I know what I'm doing. I'm just plugging in something a little bit above. -1. Nope, a little bit below. But if you need to, you can plug in that -1.1. Just remember, you're only asking yourself the sign. Why is that going to be greater than 0? A negative over a negative is a positive. Therefore, positive infinity. I didn't make a calculator. Now you might be like, once again, I could have just used the Precalc function. You're making everything harder. No, I'm getting you prepared for the nasty ones that are coming where you're like, I don't know what to do. Plugging in a little bit below, plugging in a little bit above, and we can tell what the behavior is as to whether the graph is, okay. You guys know the back of the book. You know how they don't like the snazzy mathematical notation that I show you sometimes. So just know that this one, my function is rising. No, not rising. He's going to negative infinity. What would make more sense? Falling. Whereas this one, positive infinity, is rising. Which is exactly what we saw in our graph. As far as from the left, he's rising, and from the right, he's falling. But we're showing the snazzy notations that go with that. I saw some questions, but as I go to answer them, let me move forward in one page, because some people are ready to keep going. The horizontal asymptotes. While some of you are still stuck behind.
So why is the bottom one negative again, or the bottom one positive?
Because when you plug in a little bit below, like a -1.1 or 1.01 or 1.
Yeah.
I'm going to have a negative over a he's stronger. A negative. A negative over a negative is a positive.
And then for the top one, because the negative 0.9 isn't as big as the 1. Okay.
And we don't care what the decimal is. We don't care what the 3,300 like. We don't care. We just care about the sign. So we don't need that huge table where you have to plug in lots and lots and lots and lots and lots. We just need one, to be honest. If you're really close, you just need one. Now, you may not trust me, but just believe me. When you're trying to graph these nasty functions where, okay, you've gotten rid of your holes, but it's still nasty. You found your vertical asymptotes, but that still only tells you, if you know how to analyze like this page, it still only tells you what's going on right around the vertical asymptotes. We need to know some more stuff to look for rational functions, and one of those big things is the horizontal asymptote. Now, we just reviewed some of this approaching notation with arrows. So you're going to see arrows showing up again. But this time is a little bit different. Instead of x getting closer and closer and closer to some constant, some number, and us talking about what the y's are doing, this is just a little bit backwards. A little bit opposite in that x is now going, again, to negative infinity or positive infinity. And f of x is the one getting closer and closer to a number. So we have, if you want to put this into words, you can say this is the same thing as to the right and or the left f of x approaches y equals can I just zoom in? Sorry guys, whoever was stuck on that last example. To the right and or the left as we go end behavior again, to the right, to the left. X is going to negative infinity and positive infinity. To the left, to the right, f of x is approaching some sort of y equals L. Horizontal asymptote. You guys should have seen degree test last year. If you're looking at a fraction, degree test, degree, remember, degree of a polynomial is the highest power. If the top degrees win, the top is higher than the bottom. Good stuff?
Amazing.
No. I'm wondering what they want to add. You guys want to add something? Oh, okay. That must focus. Degree of the top is greater than degree of the bottom. Then we know there's no horizontal asymptote. The bottom is the one that divides, and divides is the one that kind of holds back. But maybe we'll talk about that some other day. You guys aren't really listening for concepts today. If the degree of the numerator is higher than the degree of the denominator, there is no horizontal asymptote. If the degree of the bottom is higher than the degree of the top, there's a horizontal asymptote at y equals 0. If the degree of the top is equal to the degree of the bottom, there is a horizontal asymptote at y equals the ratio of, do you remember how to finish the statement from last year? What does COEFF an abbreviation for? Coefficients. Which might seem so basic, and in some ways it is, except it gets really nasty when you're doing an AP calculus problem having to do with limits. But once again, you guys don't seem to really be wanting to hear concepts today, so that's okay. We'll just give you the basic, and you'll have to learn a lot more when we get there. So we have 3 different examples. Usually I kind of just go one by one and make sure you guys understand, but it's all right. We're doing the short, sweet version, I suppose. That's all we want. So, for number 1, we have a squared over a single. Who wins, top or bottom? It's a little bit hard to see, but you guys should have this written down, right? So let's go ahead and zoom in on the examples so you can see them. Who wins, top or bottom? Bottom! There's a 33! No, it's not about the coefficient, it's about the degree. So, degree of the bottom wins. No, degree of the top wins. So let's figure out what the horizontal asymptote is in a second. But what case is the second one?
There's equals, so it's at
Nope,
0.
not equals.
The bottom.
Why does the bottom win then?
Because there's an
X to the first power, whereas he has technically an X to the 0 power, right?
Right.
There's nothing there. Well, that doesn't work. Just kidding. There we go. So therefore, bottom wins. We'll talk about what that means in just 1 second. And what's the last case? Equal. There's a tie. There's a tie. Okay, so as we're doing the top wins. If you guys look at your little tests on the page before, because, well, I guess we could zoom out again. Maybe some of you can see it now.
There's no horizontal.
Yeah, there's no horizontal asymptote. Long story short, if we were to do a long division, you would get a polynomial. You would actually get a linear function with a remainder. And mine just go forever. If it's not horizontal vertical, which is when it's not going to be. So therefore, it's not being, the y's aren't being held back. They're just going forever in either direction. If you want to think about the y, there's a very, very, very fast summary as to why. But this one, you could do long division. There would be like a line left over or a polynomial left over. So therefore, no horizontal asymptote. Number 2, bottom wins. There is one. There's going to be one at y equals 0. Whenever the bottom wins, there's no guessing about it. It's just going to be 0. Because basically, it kind of comes back to that parent function that Emma brought up earlier. And that parent function, always, 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 if we have a bottom winning, we're going to have that function getting closer and closer to 0 from either direction. There is a horizontal asymptote. You can look at it anytime the bottom wins. But the tie, also an HA, but the HA is at y equals, why am I putting 2? Because there's a 2. Nope, because there's a 2 over 1. Ratio. Let me zoom back in for those of you that didn't get the problems the first time. Ratio of the leading coefficients mean 2x over 1x. I look at the strongest guys. If I had more time to teach you the concepts, we talk about the champions of polynomials or of numerators, denominators, and how they determine the magnitude of the entire function and how we're only comparing the magnitudes as we go to infinity and negative infinity. The rest are inconsequential or insignificant to the infinities. But anyway, ratio of leading coefficient, 2x over 1x, which is 2. Which means, basically, this graph, somehow it's leveling off to 0. This graph, somehow it's leveling off to 0. This graph, well, no leveling off, so I don't know. Somehow it's going forever up, forever down, or forever down, forever up. So that builds us up to, whoa, here. Well, pause. Let's get back to our problem. The one that we saw at the beginning of class. I'm going to switch the order of those 2 pages. Let's do the problem first. And then we'll go back, and if you guys need any details, you can take a picture on the way out the door. Did we already factor? Yes. You guys came up with that all on your own. Nice and done. Did we already find our y-intercept? Nope. So we should probably say, okay, y-intercept is when x equals 0, right? So that would be, okay, let's go back to the beginning and say f of 0 is equal to 0 minus 4. Well, that was the grosser form. Let's look at this form. He's nice. Okay, 0 plus 2 is 0 over 0 minus 1 is negative 1. That's going to be negative 2. Okay, so I have a point I can plug in. X-intercept, that's when y equals 0. These are review, but they're hints that are going to help us out. The x-intercept when y equals 0, well, I'm going to definitely use this easier function, not the grosser one. How would I solve for the x that makes this true, guys? Just multiply, then don't you get 0 equals x plus 2? So x equals negative 2. Oh, sweet. So we have a point here. That's going to be the point 0, 2 that we're going to graph. We have a point here. We have negative 2, 0. So we have 2 special points we can graph. Vertical asymptote we already talked about is x equals 1. And with fairly quick analysis, we can figure out as we come from below or as we come from above how f of x is behaving by doing a little, ready? What's something a little bit below 1? 0.5 or 0.9, cool. You plug in 0.5 or 0.9. 0.9 plus 2 is 1, right? Or is positive. Sorry, we don't need to know the number. 0.9 plus 2 is a positive number. 2.9 is positive. What's 0.9 minus 1? Negative. Ooh, a positive over a negative means a negative infinity. You could show more work. You would plug in something a little below and check the sign. It's a negative number, so negative infinity. But 1.1, positive over, what's 1.1 minus 1? Positive okay, cool. I know what's going on around the vertical asymptotes. Horizontal asymptotes. What do we got going on? Tie. And if we have a tie, we have a horizontal asymptote at the ratio of the leading coefficients, which is 1 over 1. We could start doing a sign chart too if we want, which is where we would make a table and say, okay, so we know some good stuff. We know some good stuff, but we might want to know a little bit more. So we might go ahead and think of, okay, so in our number line, if we were thinking of the x-axis, we know what's going on at positive 1, being a vertical asymptote. We know what's going on. Let's make it big, because maybe we'll get the whole, there we go. The whole function. Let's see what we have, and let's see what we need. We know 0, 2. We know negative 2, 0. We know a vertical asymptote at 1, where the function is coming in to negative infinity and to positive infinity. We know we have a horizontal asymptote at 1. Oh, you know what? I'm going to guess, but maybe I would plug in a few more points just to make sure I'm right. I would guess it's just going to curve down to the horizontal asymptote. I would guess it would curve up to the horizontal asymptote. I think I got me a really good picture, but how would I make sure? I would maybe plug in just a few more points. In those little, like, ambiguous, I think maybe I'd plug in a point. I think maybe I'd plug in a point, but otherwise, we have our vertical, we have our horizontal, and we have our All right, let's see how homework goes to you guys. I probably would have plugged in, since this is 1, I would have plugged in like maybe a 2 or a 3. Just to be like, okay, here's what's going on, really what's going on. Then I might have plugged in somewhere around here, just to make sure that there's a negative 1. And I would have plugged in somewhere over here, maybe there's a negative 3. But as long as everything matches up.
Thank you.
I'm so hyped.